talk about today is there's now a data deluge, a big data deluge. So geospatial data volumes are growing at an ever-increasing rate, and they're faster than processing and than storage costs are falling. So actually data is outstripping the evolution of technology when it comes to storage and processing time. So we now have data coming at us that is a greater resolution, greater coverage, and also a greater frequency. So we're getting more data more often. And this data is coming in a number of sources. So we have the usual sources, which was providing the data for point cloud through terrestrial laser scanners, which could be used on buildings internally or externally or on bridges. So they have now improved. These tools are a lot more accurate. They can also do a lot bigger resolution, and they can do it a lot faster. So this is growing the amount of point cloud data that's in existence. We also are now getting point cloud data from other sources. So you're getting this information from UAVs and UASs, such as this AI Botics drone that we see here. And of course, we can also get point cloud from mobile mapping sources, like this Pegasus 2 mobile mapping from Leica, which can generate point cloud data at a speed of 70 miles per hour when it's driving in a car. So really, there's so much data sources now for point cloud that we can actually, it is growing, and we need to be able to handle that point cloud and have applications that can use the data so we can analyze it, we can make decisions from it, and also have applications that can store the data and share it. So this morning we're going to talk about two of those applications. The first being Imagine, ERDAS Imagine, which can be used to analyze and classify and generate maps from point cloud data, and Glenn will be showing that this morning. Then later on, I'll also talk about Apollo, which can be used to store point cloud data and also share it up and through web services and provide it through multiple devices, not just tech clients like ERDAS Imagine, but also through thin clients and also on mobile devices. So starting off with Imagine, it's a comprehensive all-in-one geospatial authoring platform. So it's a one-stop shop for radar, multispectral, hyperspectral, terrain, point cloud, photogrammetry, and basic vector analytics. It has advanced multi-core batch processing and it's a real-time advanced spatial modeling environment. So it keeps it simple and powerful. And with Imagine, we provide there's an increasing variety of data that Imagine can use. So you've got vector data, aerial imagery, satellite, thermal radar, and of course point cloud that we want to talk about today. And with that data, you can then create actionable information. So you can visualize it, you can enhance it, measure it, classify it, and analyze it, and then create end product maps. And again, Glenn will be showing that later on. So on the analysis side of Imagine, you can do image classification, enhancement, change detection, which again, using point cloud data is becoming very important to find where new buildings are, where changes in the landscape are happening, spatial modeling, slope and aspect, proximity analysis, and pan sharpening. But the big thing with Imagine and why we're speaking this morning is point cloud handling. So Imagine has a series of point cloud tools that can have you bring in the point cloud data to visualize it, and then to also then to RGB encode that data so you can make better sense of it. So you can see here a nice car park. But also then we can also look at the point cloud data in a variety of different views, from the longitudinal profiles from above, in 3D, in whatever way you want to make sure that we can understand the information. And you can do layout windows like this and see the whole strip of the point cloud data. This example is where a power line was surveyed using aerial LiDAR to show the point cloud for that area. And you can see the vegetation, you can see the electrical lines along that line. So I'm going to hand over to Glenn, who's going to give you a demonstration of point cloud analysis in Imagine 2014.
Good morning, everyone. I'm going to do a run-through of some of the common analysis and visualization techniques using LiDAR point cloud data with Imagine. So, just have Imagine here. And first I'm going to set up a shoebox, which is a nice container to hold the files that we'll be working with. So we can add new shoebox from here. We can add files. So I'm going to add in point cloud data set for Dublin City Centre. in the shoebox. Also, I'll add in an ortho image of the same area. And from here we can just drag and drop into the viewer. So you can see here we have our point cloud. If we zoom in, you can see the points that make up the data set. Here we can view this in 3D. So here we have elevation values ranging from the low blue to the higher reds. So I'll just going to open the ortho image now, the same area. Hit the frame. From here we can use a swipe tool, see where the matching elevations are for the features in the ortho. Next I'm going to RGB encode the original point cloud data that we have here. Here our input file is our original data set. We'll save this to an output file. And we'll use the ortho image to RGB encode it. So what's happening here is it's taking the RGB values from the ortho image and assigning them to the pixels of the LiDAR point cloud. So this should provide a photorealistic point cloud for us. So I'll add that new file to our shoebox. Drag and drop in. So you can see here it looks similar to the original. We can change the color of that to our RGB. Again, do that in 3D. You can see now the features are easier to pick out, the buildings, vegetation. Here we can take some measurements. We'll draw a rectangular profile around the forecourts. Should split the screen into several views. Up here we have our 3D view. You can see the bounding box that we drew. Here we have a front view profile and a side view profile of this bounding box. We can increase the point size to see it a bit better. Here we can use a measurement tool. Measure from ground to the top of the dome. That's about 40 meters. You can take notes. You can insert notes here if you need to.
And actually, just notice the bounding box for in the top right-hand corner. It's actually 3D itself. It actually is the full building. First time I've seen that. That's pretty cool. Yeah. Okay.
I'll just close these down for now, and I'll move on to doing a simple classification of the original data set. This is our original point cloud data. On a simple classification. Just change a couple of parameters here. We'll set the max height for low vegetation to 0.5 meters and the min height to 5 meters. So we've only just set a couple of parameters there. So what's happening here is that the original point cloud data has been classified into 3 separate classifications. We'll have the ground, vegetation, and buildings. It's important to note here this is generally an iterative process, so it's rare that you'll get the classification spot on the first iteration. But it'll just show how powerful it is just to accept most default parameters. That does pretty well. again, we'll add our new file to our shoebox. And drag and drop again. Again, it'll look like the original until we change the color by classification. So you can see here, the brown's the ground, the green's the vegetation, and the red are the buildings. Show that again in 3D. There we go. You can see here down by the keys, the vegetation standing out from the ground, the buildings. You get a few remnants of where you need to go back and do another iteration for your classification as you get to know your data, the heights, the areas of the buildings. From here I'm going to filter out the ground and the vegetation so we're left with only the buildings. So we only want our buildings. Add that again to our shoebox. Drag and drop in. These just our buildings there again.
So in essence what you've done there, without actually having to draw a single polygon for a building or digitize a building, by taking the point cloud data and running the classification, even a very rough and ready classification, you're able to extract, you now have all the building features there, and of course you could do some advanced spatial modeling with this in the future and take away the buildings that you already have on your map base, and then you'd be left with new buildings. Yeah. So it's a very quick way of getting that data as opposed to having it around in 2D and drawing it all out.
Yeah,
it's really good.
So I RGB encode this earlier. You can RGB encode the file again with just the buildings. So I'm going to add that. Show that on its own. RGB. So you can see here, all we have left is the buildings. There's a bit of remnant vegetation because we didn't really refine our classification. But you can see if you do, look down here, it's just all the buildings that are left, photorealistic buildings in 3D. So that's the basic analysis for the aerial LiDAR. I also have a terrestrial data set. I'll show you now. This here is the Lewis Bridge in Dundrum. This is a very high resolution data set compared to the aerial that I showed you there. We will view this in 3D first as the pseudo color. This is quite a large data set, just over 1 gigabyte in size. So I'll take it.
So this would have been captured. I think it was captured by SIS out in Dundrum. They were using the Leica terrestrial point laser scanners, so they can do this kind of high resolution, quick capture just by setting up a laser scanner on the street there, probably coming down from Ballantyre Avenue.
You can see here already the detail that's coming in. We can see trees. We can see the lampposts here and here. This is already RGB encoded for us, so we click the RGB.
What's your spec a laptop, Glenn? What's that? It's not a high spec laptop. I think we can assume.
Yeah.
The one thing with this kind of stuff is you do need kind of high-rise graphics. And,
yeah, you want a 3D graphic card that can really handle it.
And probably a good processor as well. Yeah.
And I'll show you, we did a rectangular profile last time with the forecourt, so I'll do a polyline profile this time across the bridge.
That's really good. Yeah.
Just split it into several views. The overall profile and side profile.
And that's just the last file, is it?
This is the last file, yeah.
Okay. So that came from the scanning company. Did you have to do anything to bring it into Imagine?
Well, there's LAS is the most common way of transferring point cloud data, but it does also come in different formats. So we actually did convert it from the version, the format they gave it to us, into a LAS file, and then brought it into Imagine.
And what did we convert it?
FME.
FME. Yeah. Okay. So yeah, that's one we aren't talking about today, but FME, of course, has a lot of point cloud operators for bringing data in and out, so it fits pretty well with Imagine. And Imagine, I think it's something that's coming in next year's release. So is they're going to have FME operators inside Imagine, so that you can actually use some of the FME tools in Imagine, and it could be vice versa in FME as well. So watch this space. That center image.
Yeah, so the 3D view.
Yeah.
Here we have our overall profile as we go across the bridge. Here's our front view profile and a side view. And you can use profile roam to roam through the different profile steps.
Okay.
You can play through, you can pause, you can stop, make measurements again. Just as a quick note there about the size of the LAS files, Imagine handles both LAS and LAS files. So a LAS file, LAZ, is a compressed version of the LAS file. It's a lossless compression, so no data is lost in the process. ERDAS Imagine will uncompress on the fly as you bring it in. So this LAS file is 1.01 gigabytes, but when compressed through the LAS, it is 168 megabytes. So you can see for the storage of data, it does decrease the file significantly. You can see here that Imagine can convert between LAS to LAS. So you can save on storage space, the more data that you produce. And that's it.
Okay. All right. Thanks, Glenn. So neatly moving on from Glenn's point on the storage, I'm now going to talk about Apollo, which is the solution which can be used to have store your point cloud data, but also share it up and catalog it and disperse it around your organization. Okay, so let's get the slide back up here. Oh yeah, and just before I go on to Apollo, we have coming in 2015, which is just about to hit the floor, hit the road. It's just, I think it's the CDs and things being burned as we speak. There's going to be point cloud compression and streaming in Imagine 2015. This format will be used hexagon-wide, so it'll also be used by those kind of Leica laser scanners. And it's a new format for compressing point tools, point clouds, and its result is 10% of the original size, access will be very fast, and it'll also include generalization, so you can do pyramid layers again to decrease the size, and we'll have the ECWP protocol to stream from Apollo into applications. So just to show you that, so you've seen the speed of Glenn's when he was taking the point cloud, the high-res point cloud on the laptop, but here it's using streaming, and you can see the very high-res data, but it's coming in pretty quickly. And we'll have this out, and we'll be showing it probably in January, February, March. We'll be doing demonstrations of the new 2015 functionality in Imagine and Apollo. Okay, so with this point cloud data, there's rising user demand. So every day, new users are demanding this type of imagery in point cloud across all applications on a variety of devices. So there's an increasing need to leverage this amount of geospatial data, and people want dynamic discovery, so they want to know where data is, and they need to be able to access it quicker, and then going to use it for many more purposes than they have done before. And there's an increasing pressure on companies and data managers to ensure that data is available, stored properly, and accessible. So what ERDAS Apollo provides is a comprehensive data management, analysis, and delivery system, enabling an organization to describe, catalog, search, and discover, and securely disseminate massive volumes of data. So it solves the bounding box problem. So at any area, it'll tell you what data you have at any location, be it sensor data from LiDAR or point cloud or radar or spectral, to location reference data and structured data, to normal geospatial data, and then unstructured data. And what Apollo provides is a wizard-driven workflow to catalog and publish. So you can search any file system, you can set your schedulers to repeat the search on a given time, and then you can process and set security to control access by user and resolution and location. So Apollo will catalog all your data so as you know where it is. So when all this point cloud data is coming in different file formats, you can automatically add that to a catalog. You know where the information is, and then you can access it later. Also, with this point cloud data, you're going to have the challenge of growing data sets and size, so you need to be able to compress data. One area that Glenn mentioned already was converting the last file to a LAZ file, a compressed last file. But the other option we have is ECW image compression, which allows you to compress the data and have reduced data management and enhanced performance. And one study we have of this is in Germany, where they took a 38,000 gigabits imagery, mosaicked the file, created a single ECW file, which came in at under a terabyte. And then that file was able to be accessed on a phone. Because it's using ECW pyramid technology, you could view the whole country of Germany, and then the image only downloaded the pixels you needed as you zoomed in. So ECW compresses both imagery files into manageable sizes while preserving their visual quality. And we also have the ECW protocol, which is the world's fastest streaming of ECW and JPEG imagery. So how does this reflect into LiDAR or point cloud data? Well, with Apollo you have the requirement to manage large number of LAS files. So with Apollo we can catalog that data, and then end users can discover, view, analyze, download, and subset and mosaic data. So we treat the LAS file like raster, so we converted the data to a raster file, to an ECW file, and then because that makes it easier to view and easier to distribute. And we also can automatically then create grids. Then that data is available via WMS, WCS, coverage service, or WPS, but you can also download it or clip, zip, and ship. So in Apollo, we've got our data manager that allows you to catalog the LAS files. You can then edit that metadata, and then it can be discovered through the geospatial portal. So anybody using the web application on your corporate browser can actually access this information. And then we have our clip, zip, and ship. So clip, zip, and ship is LAS formatted point cloud data, where you can select the clip area, select what classifications of the LAS file you want to bring down, filter it, and then the output will be either to a LAS file or to an image or TIFF file. So I'm going to show you some of this now. Go on to my browser here. Oh. Okay. So this is Apollo on the Hexagon Geospatial site. So the first thing I want to do is I want to go in. I'm interested in this area, but I want to see, is there any point cloud data that I can actually access? So what I can do is just go into the catalog. I can type in point cloud. I'm going to take data sets and aggregates. And I'm going to say, well, I only want the data around this Las Vegas area. So I'm going to have a spatial filter, and I'm going to leave that set to only visible in the current map area. So again, instead of me downloading the whole data set, it's actually going to bring down the data I need. So then I can go in and hit the search button. And if I wanted to, I could also put in some dates, but I'll just take all these. So you can see in my control here now, I have the data has come back, all in a list with some simple metadata. And you can see you can have them in a list control, or I can say view them as thumbnails, and then they'll appear as just some simple thumbnails. So then I can click on the 5 bits of information, and I can zoom to them. And it'll show that data, and you can see in the center of the map here, they have now highlighted and showed the information. I can also pick the metadata for those sets, so I can have the index metadata, and it'll pop up here, and you can see each file has its own metadata that's already been captured in the catalog. So we know when it's captured, the resolution, the coordinates for the area, everything I need to know. And if I even want to see ISO metadata, I can do the same, and up pops the ISO metadata. And then you can see that the ISO compliant metadata is then shown for each of the features. Okay. But actually what I want to be able to do is to add this data to be sent to an email, or I'll be sending it to Glenn's email. Yeah. Yeah. So what I'll do is I'll pick my last file here. Sorry, yeah, pick 2 last files, and I'll say I'll pick the 4 here. And I'll go add to clip, snip, and ship, and up pops my clip, snip, and ship. So it's putting Glenn's email address because I'm using his machine. Right. IMGS.ie. And I'm going to take on the coverage options, I'm going to send the last file. I'm going to pick my classification, so I'm going to take the low, medium, high veg, so take all the veg and the buildings, and I'm going to send that and hit submit. So now it has sent that data off to Glenn's email account. So if I go in here into the Outlook and we go into inbox, first thing we see is we get an email from, oh yeah, blocking me there, another one. Okay, so yeah, it's just getting pop-up blockers here. Yeah, so we can see the first email it sends in and says, we've got your request, we'll come back to you soon with the data. So we'll then just wait for the next email to come in, and that email then should have the email that we need. So we'll give that a second. So we've now taken the data out, we've sent it out, we've now attached the file, and we can see it. And then once it comes in, then we should be able to download that last file and open it up in Imagine. Just while I'm playing here and waiting for the file to come in, I can show you the geospatial portal. So I can actually zoom around on this data. They're all interactive maps. We can see the data we've downloaded. We can add web services. We can zoom in. We can zoom out. And we can zoom to previous. So again, very easy to use. You've also got your map content, but like any other web application, you can turn on and off map layers. You can add layers by using the add layer data sources. You can add in web services on the fly. And you can also go into the catalog and actually see all your data in a folder structure. So not only do you need to, so you don't have to always do a search, you can actually just drive down and actually look at the information yourself. And you can see all the data. As I click through the features here, you can see the metadata and see the data as it's coming in. So again, very easy to use tool, and you can also have geoprocessing. So any of the spatial models that Glenn was creating in Imagine can actually be published out through Apollo. So again, we have one here which is vegetation change, but when Glenn ran the classification there to extract the building polygons, somebody could actually do that through Apollo and not actually have to run Imagine, just have to run the model and get the answers and get the information out or see it on a web client. And then you can do painted relief and things like that as well. And then you have your measurement tools, and I was showing at our geospatial user group, we can also do things like time sliders and time controls to actually see data. So go back to the email here, and we now have the file. You can see it's been sent through. I can click on that. I can save as, and we'll put it in there. It's just download. Yeah, and that's coming down, and our broadband's a bit slow because considering we're downloading a file and doing a webinar up, I think it's probably eating up the bandwidth. So, do you have one we've done before? No. Okay, it's coming. All right. Okay, so we'll let that download, and I'll finish off the slides, and then we can come back, and Glenn can show you that file as well. Oh, wrong slide. Right. And we go down here. Okay, and so yeah, and as I mentioned already, you can do geoprocessing through Apollo. So one thing that's coming for 2015 is you're going to have the ability to do some of this processing through the cloud. So if you actually don't even want to have the Apollo yourself, but you want to be able to call some of this kind of advanced geoprocessing tools, there will actually be cloud services that you can use for things like compression and for doing analysis through the cloud, and we'll be talking more about that in the start of next year. Just on the webinars, the next webinar is going to be another webinar on Smart Client. We've added some new workflows I'm going to show, and Amanda will be announcing that pretty soon. But all our webinars from this year, we've been very successful with the webinars since we started them in April, May. We are all online, you can get them, so pretty much all our product sets now are covered up there, and you can use them and hopefully get good use of information out of them. And just some events are coming up. We'll be talking about this kind of topic again next week at the Irish Earth Observation Symposium out in now called Maynooth University. Maynooth, even better, Maynooth University. So I'm doing a presentation on handling big data, and again, very similar to what we're talking about today. And Glenn will be giving a workshop on Point Cloud, and he promises me he's going to have something new to show as well. So the Point Cloud workshop, and we're also going to be at in Geodata in Belfast on the 20th of November at Stormont Hotel, and I'll be talking about Smart Client then. So hopefully now if I go back out, we should have that file. It looks like it's getting there. It's 71%. Okay, well you can take our, we won't hold other people up. Yeah, we've got some questions, so we'll take the questions. Amanda?
Okay, I had a few questions come in around Glenn's demo. So the first one was, is this data on a local drive?
On the hard drive to the computer. It's on my C drive.
Yeah, yeah. So again, with the 2015 release, you'd be able to stream that. But of course, yeah, you could use the data on a file share, which a lot of people would use. But again, depending on the size of the point cloud data, you may not want to be bringing that across your network, so you might copy it down. But that's where the Apollo comes in. It allows you to copy down what you need to work and then edit in the local machine.
This also came in during Glenn's demo. Will the new compression work on already compressed files such as POD files?
Yeah, I think so. I think the quality of the file and what it would need to do, we may need to convert that POD file to some kind of image and then be able to compress it. So we can, I know where that customer's coming from and who it is. We can check that one again. I'm not 100% certain, but I think we can compress the file. Okay, yeah. Yeah, I think someone said the data seems a bit slow. The laptop that's being used here today would not be a high-spec laptop. So I think a better laptop with higher graphics, and I suppose I'm going to get a request from Glenn now for a better laptop. But yeah, I don't think the laptop would really be well, it's not a high-end workstation. So that's probably why it could be faster on a more powerful laptop. Next question.
How much work is involved in cataloging data? What data is required to catalog?
Well, the cataloging is pretty simple now with the new versions. You just set up the scheduler, and it then goes off, and it'll check any file locations that you set up. So it's a case of just going around and saying, right, check these folders, and you have to tell them which folders to do. So depending on how many folders you have to set up, then that then defines how long it's going to take. But it is pretty simple, and with the 2015 release that's coming out in December, January, it's also going to have the ability to catalog spatial databases, which it didn't have before. So again, you can pretty much catalog anything. So what data is required to catalog? Well, any data really. So from 2015 on, spatial databases, SQL Server, Oracle, CAD files, shape files, and all forms of text files can all be spatially cataloged. Okay.
Next question. Can I store point cloud in spatial database and push it out with Apollo to other applications?
Yes, that you could do that. Not sure how efficient that would be. Your spatial database might get pretty big. Our normal approach would be to actually store the point cloud on a server, maybe compress it to ECW or to raster, and then it could share through or Apollo. You could definitely, in the Apollo catalog database, you could store the metadata where it would say where the files are stored, the last files. That should be pretty efficient. But yeah, okay. I think you probably could, but we would say compress and store would be our way.
And there's a slight continuation on from that. And also, can you do feature extraction in relation to assets management?
Yeah, definitely. That's then Glenn showed on Imagine, but you can run this through Apollo because every process that you run in Imagine can then be published out to Apollo. So you could run an automatic feature extraction. You have to take out buildings or bridges or whatever you want to do, as long as you can come up with the rationale to say this is what it is, and you can classify by that. Can you clip, snip, and ship scalable images? I'm not quite sure that question. Clip, snip, and ship. Well, yes, you can, because you can export out the ECW images, or you can send the clip, snip, and ship can actually download the data as image file. So yes, I think so.
Isn't all the cloud-based processing heavily reliant on very fast 5G internet connection?
Yeah, so that's a very good question. Yeah, so with cloud, it's only really if you have a fast connection and you want to do something maybe for a day or something, and then you might use the system again. If you are regularly doing big amounts of data, we recommend a local system.
What metadata is required to catalog?
The metadata is really up to yourself. We do support ISO. We can also build Inspire compliant metadata, but you can set up your own basic schema of just simple things like name and date. And a lot of the metadata can be automatically populated, so you don't actually have to manually enter the metadata. So it's really up to yourself. You can have it that if this is a last file, then it says it automatically assigns it as point cloud. If it's a movie file, it automatically puts it as, or an MPEG file, it automatically puts it as movie. Okay.
Next question: can you also display panoramic images overlaid to point cloud data from mobile mapping systems?
Panoramic images. Yes. Yeah, you definitely can. Whether it does it fully panoramic, I'm not sure. Definitely the imagery can be displayed, so you can take in your imagery, put it against the point cloud and show them together. You can do the swipe, just the panoramic piece now. Would it smoothly go around the corners? I would say so, but I would need to check. I think some of these questions are definitely very good questions, but we may need to issue some clarifications after the meeting as well. Some really good questions.
Yes, and just point
out. And sorry, on the mobile mapping systems, definitely we can take in mobile mapping terrestrial data. There's no problem there.
So yeah, I'll definitely make sure the recording is available online. If anyone didn't make it to the webinar today, and also with the frequently asked questions here. One more just came in there. How does it interact with trajectory data?
There's blank looks on this side. I think we're definitely out of our depth today. We will find that out for you. Trajectory data, I'm not quite sure how it works with it, but we'll answer that in the issue afterwards. And I think any more questions? We'll give it. That was really good. A lot of questions. Yeah, the a lot of good questions today. Really, very good attendance again. I think again one of the record attendances. So I hope you enjoyed today. Oh, Glenn, have you got our file?
Well, it's there, yeah.
As you can see, our bandwidth is not great either. So if you can open up that file if you can.
The point cloud one?
Yeah, should be in it. Yeah. She's bringing it in. So we get all the questions, Amanda. We haven't missed any there because we're flying in there. So you can see the last bit we're going to show is that there's the data that we downloaded, extracted. You can see it now as a point cloud fitted onto the desktop, and we're able to see that information. So very easy way to get data stored on the server, extract it and use it locally, and then when you're finished you can push it back up. Okay, so that's again. I think we got a few good questions there. So we'll definitely review those questions again and issue them to all attendees. Thanks for thanks for your input today. It was a really good session. As Amanda says, the webinar will be up online an hour or two after the event. If you need any more information, please please email either Amanda or myself, and we can provide more information or come out and talk to you. So hope you have a nice day. The wind is starting to die down around the country, and thanks to Amanda and Glenn for their help. And we'll talk to you next month when we go about the smart line.
Yeah. Thanks very much.
Cheers.
Thanks. Bye bye.